Okay, so this is my maze navigating robot for Comp 444. This is, I've lost count of how many trials, but we're essentially trying to use a landmark-based maze to navigate the course. I might finish that final wall in blue, but essentially we're just trying to get to this green end zone. So it's programmed just to recognize yellow and blue right now, but let's see how it does. The obstacle sensors, so it's essentially a hybrid-based control system. There we go, that's what should happen. The obstacle sensors are recording the front distance, and that might be a problem. Yep, now it won't recognize the color. Yep, now it's not. Oh, that time it did. Yellow's been particularly tough for this bot. Oh, there we go. Come on, see the blue. See the blue. There we go, and yeah, that's what we call winning. Okay, and before it kills itself, I'm gonna stop that. So yeah, effectively what it does is it's using a Raspberry Pi camera on the front of the bot there, and OpenCV to recognize colors. And once it's within a certain distance on the front obstacle sensor, it will try and detect if it's a certain color that it recognizes. I can't tell you how much trouble I've had with yellow. That's why there's even a yellow ruler sticking in there. Blue was far easier to get recognized, even playing with the parameters. I would probably think green is yellow at this point. And white, it's supposed to recognize as no landmark and just an obstacle to be avoided. There are these infrared obstacle sensors. I had played with them. I just haven't removed them because honestly, the frustration of rewiring it would have taken too much time. But those I had played with initially as being the side-based sensors, that there would only be one ultrasonic sensor at the front. But I just found they were so unreliable in terms of actually executing, like sensing an obstacle accurately. They would get banged around, and then they would sometimes be transmitting too often and would screw up a good path, sometimes not enough, and it just didn't have like the specificity of range. So very fancy, you can tell with the elastic bands. But I use those to basically keep the two side ultrasonic sensors, and I set side parameters to essentially say that if it came within a certain distance of the side, and I know they're at an angle, so it wouldn't be as precise as possible, as ideal, but if it came within a certain distance, it should do a small, super short turn to correct and account for that, to help it navigate in the proper, or set its course more away from any sort of side obstacle it might be encountering. The front obstacle sensor or ultrasonic sensor was only used for avoiding obstacles if it didn't recognize the color. So essentially, if it was white, it would treat it as an obstacle and just sort of back up and then either do a random turn left or right away from it. But if it did recognize the color as yellow or blue, it would execute a turn based on which it was supposed to use. So for left, it was supposed to, or yellow, it was supposed to turn to the right, and blue, it was supposed to turn to the left. So yeah, not as ideal as I would like it, but I can't tell you how much time it has taken just to get here. And I'm a teacher on the last day of summer, about to go back to school. So I imagine life is about to get pretty busy. But yeah, that is my maze navigating robot using computer vision to recognize color and a landmark-based map to help it navigate the maze. And yeah, it's a hybrid control system because again, it has sort of a bottom reactive layer meant to avoid obstacles, but the planning layer can interrupt that if it detects a landmark that should change the robot's behavior. So yeah, this is my final project for Comp 444, and yeah, don't know what I'd call it, perhaps Dodo. All right, that's it for me. Thanks for watching. This is Brennan Stanford for Comp 444, final project, landmark-based maze navigating robot out.